In several large market segments, especially those that deal with a time-sensitive good or service, you can segment customers into valuation groups. High valuation groups are willing to pay more for the product or service, while low valuation groups are only willing to pay a lesser amount. This afternoon, we're going to explore how the airline industry segments customers who are willing to pay more for a ticket from those who will only fly on discounted fares. You're probably familiar with the old method airlines used for this. If you were willing to spend a Saturday night at a destination, you could get a significantly cheaper fare. That method segmented business travelers from leisure travelers. Unfortunately for most airlines, the public now sees them as a replacement for driving long distances or riding buses. The Saturday night stay method has fallen out of use in favor of methods that use how far in advance the ticket was booked. In general, the closer people book a ticket to the day of the flight, the more they're willing to pay. Let's pretend that we've been hired by Malaysia Airlines to help them maximize their revenue on flights between Amsterdam and Kuala Lumpur. We've conducted some basic research and asked 2% of potential passengers their valuation of the flight. We only had to ask 10 people. The airline's business seems to have dropped off sharply for some reason. This is the table of the raw data from our survey. The 10 valuations we have are functionally the same as 10 points on the demand curve for the flight, which is enough for us to calculate the entire curve. What we need to do is sum up the number of people who would buy a ticket at each of the 10 price points. That's the demand at each of the price points. For example, if we charged a single price of $700 for the flight, 5 of our surveyed passengers would buy a ticket because 5 of our surveyed passengers value the flight at more than $700. Let's open a new Excel workbook and enter the 10 fare valuations our research turned up. We can have Excel sum up the number of passengers who would purchase at each price point using the COUNTIF function. Enter the formula and accept it. Select the cell containing the formula and drag the selection box down using the handle at the bottom right corner of the cell. This will extend the formula to the remainder of the demand count cells. Since our survey data only covers 2% of the potential passenger market, we need to multiply our demand levels by 50 to make them represent the entire market. Enter the formula to multiply the first demand level by 50 and accept it. Select the cell containing the formula and drag the selection box down using the handle at the bottom right corner of the cell. Again, this will extend the formula to the rest of the cells in the column. Select the cells containing the prices and the demand levels at each price. Navigate to the Insert tab, click the Scatter option in the Charts group, and choose Scatter with Only Markers. Our next step is to get Excel to draw the demand curve for us based on the data points. Recall our basic formula for linear demand curves, where D represents the demand level at given price P. Excel will automatically calculate the values for A and B for us as part of drawing the demand curve. Right-click any of the data points in the chart and choose Add Trendline from the context menu. In the Format Trendline dialog box, choose the Linear Radio button and check the Display Equation on Chart checkbox. Then click the Close button. Excel gives us the plot of the line connecting our 2 points, along with the equation for the line. If we plug our values for A and B into the linear demand curve formula, we end up with this equation. To illustrate the effect customer segmentation can have on revenue, let's calculate our maximum revenue if we charged every passenger the same price. We're going to cheat just a little bit and ignore the fact that airplanes have a fixed number of seats to keep our model simple. Start by entering a guess for the optimized price. It doesn't have to be accurate. Excel just needs a place to start working from. I'm going to guess $400, but you can use whatever you like. Next, enter our demand curves formula and accept it to calculate the demand level for tickets based on the price. Our total revenue is the optimized price of a ticket multiplied by the demand level for tickets at that price. Enter the formula to calculate revenue and accept it. Now, we're ready to let Excel's solver tool find the optimal price for our plane tickets. Navigate to the Data tab in the ribbon and choose the Solver option. We want to maximize our revenue by changing the price we charge for tickets. We're going to use the GRG nonlinear solving method. Go ahead and click the Solve button and put the solver to work. When it completes, it's going to tell us the price we should charge for a ticket to maximize our revenue. Click the OK button to dismiss the status dialog solver displays when it finishes. If we charge the optimized price of $599 for tickets, we'd see around $250,000 in revenue. So let's move on to what we really want to do: charge some customers more for the same ticket to increase our overall revenue. In an ideal world, at least from the airline's perspective, we could charge each customer a different price based on how rich they are, or how desperate they are. But that's basically illegal, at least here in the US. It's considered discrimination. What's not illegal is using a price segmentation strategy called yield management. As long as we can identify a variable that's strongly correlated to how much a passenger is willing to pay, we can charge different prices based on this variable. In the case of an airline, our strongly correlated variable is how early a passenger buys a ticket. In other words, low valuation customers tend to purchase a ticket well before a flight, while high valuation passengers buy tickets at the last minute. We can model this behavior by incorporating two price points into our model. The demand formula for our high price point is going to be the same as our basic one price demand formula. But the demand formula for our low price point is going to be our basic demand formula minus the demand for tickets sold at the higher price point. Let's go back to Excel and start working in a blank worksheet. Enter guesses for the high and low price point. Again, it's not that important that these even be remotely close to the actual prices. Excel just needs a place to start working from. These are my guesses. Feel free to enter your own. We're all going to end up at the same place. Enter the demand formula for our low price point and accept it. Enter the demand formula for our high price point and accept it. For both price points, the revenue is the optimal price multiplied by the demand level at that price. Enter the revenue formula for our low price point and accept it. And then enter the revenue formula for our high price point and accept it. Our total revenue is just a simple sum of both revenue streams. Enter the sum formula and accept it. Now we're ready to optimize our pricing using Excel Solver tool. Navigate to the Data tab in the ribbon and choose the Solver option. We want to maximize our total revenue by changing our high and low price points. We're going to continue using the GRG nonlinear solving method. Click the Solve button and Solver will zip off to find our solution. Click OK to dismiss the status dialog Solver displays when it finishes. Our optimized model indicates we should charge a high price of $799 for last-minute passengers and a low price of $399 for advanced reservations. Basically, we've just increased the airline's revenue by 33% for this flight. So our model still has one problem we need to fix. It's working under the assumption that there's an unlimited number of seats on the plane. Since we don't want people sitting on the wings and hanging out the landing gear bays, we need to add a capacity constraint to our model. The plane Malaysia Airlines flies on this route, a Boeing 777, holds 341 passengers. We want to make sure we don't sell more than 341 tickets for the flight. The total number of passengers in our model can be calculated by adding the low price demand level to the high price demand level. Enter the formula and accept it. Navigate to the Data tab in the ribbon and restart the Solver tool. Click the Add button to add our constraint. We want to limit our total number of passengers to be less than or equal to 341, the number of passengers the plane can hold. Click the OK button to set the constraint. Click the Solve button and Solver will re-optimize our model, taking into account the constraint on the total number of passengers. When Solver completes, click the OK button to dismiss the status dialog. Now, we see that we should charge a high price of $955 and a low price of $711. These updated prices force our total demand fit inside the airplane's capacity. Note that the addition of the capacity constraint dramatically increased the price of the tickets, which you would expect.